Over the course of 3 weeks, we studied California's geological history and how our state came to be. This is the story of California's geological past by Morgan and Adrena. Pangea. The separation of this continent occurred roughly 335 million years ago. During this time, fragments of Earth split and moved apart to form our current map. These fragments of the Earth are best known as tectonic plates. The continental plates move on an average of 2 to 5 centimeters per year, and these plates are made of multiple rocks formed by nature hundreds of millions of years ago. Rock classification. The rocks that each plate is made of are classified into 3 categories. 1 is sedimentary rocks, which are layered rocks formed at Earth's surface and made through weathering. 2 are metamorphic rocks, which are formed from heat and pressure. Number 3 is igneous rocks, which are made when magma solidifies and are sorted between intrusive igneous rocks, which means that they are crystallized below Earth's surface and show large crystals, and igneous extrusive rocks, which erupt on the surface and cool quickly to form smaller crystals.
The Franciscan Complex. The Franciscan Complex is made of a complex assemblage of deformed and metamorphosized sandstone, shale, chert, and basalt. Layering and other internal structures are caused by internal movements. The rocks in the Franciscan Complex are between 200 million and 80 million years ago. This rock formation is called the Franciscan Complex because of these rocks' prevalence in San Francisco. The internal structure of the Franciscan plate is very complex because the layers of sedimentary rock are deformed and the rocks are altered by faults and shear zones. This jumbled mess of rock is called a melange. The rocks found here are greywacke, shale, chert, basalt, and plutonic rocks. These rock formations were formed by metamorphism because of heat and pressure.
The Great Valley Sequence. The Jurassic Age was 165 million years ago. During this time, igneous activity became less apparent in the Sierra Nevadas, which is why the summits became eroded. Then, rivers washed away the volcanic bedrock and pushed it into the Great Valley Sequence. The Great Valley Sequence is a large mass of oceanic sediments. The sequence surrounds the Great Valley and the rock layers dip towards the center of the valley. These layers are composed of sandstone and shale, and they were formed during the Jurassic Age, which was about 165 million years ago. At this time, the entire area was deep underwater. After the layers were formed, the ocean was drained out of the Great Valley Sequence. This caused loose sediment to wash into the lowland and eventually end up in streams and riverbeds. At this time, volcanoes in the Sierras and Cascade Range became active, which caused magma to flow into the Great Valley. Then, about 25 million years ago, the northern part of the Great Valley began to fill with volcanic material. Today, rocks found here include layered sedimentary rock made of shale, sandstone, mudstone, and mudstone interbedded with sandstone.
The San Andreas Fault. About 100 million years ago, the west edge of North America collided with the spreading ridge as the Farallon Plate was subducted. This collision made the Pacific Plate come in contact with the North American Plate. The San Andreas Fault was created when 2 plates shifted and made a transform plate boundary, where the plates laterally slid past each other. Now, this is the best-known fault in the world, identified as a right lateral strike slip between North American and Pacific plates. The San Andreas Fault moves northwest at an average of 5 centimeters or 2 inches a year. This movement seems small, but this means it has moved 185 miles since the transformation boundary originated. Other faults in the area are the Calaveras, Hayward, and San Gregorio that are roughly parallel to the plate boundary. The area produces many earthquakes and lots of seismic activity.
The Sierra Nevadas. The gold rush started in 1848, and people found 3 sources of the placer gold. The first and second sources were from the Eocene river deposits, in both modern rivers and fossil rivers, which were rich in gold. The third source of gold was found in the veins of quartz. These gold-bearing quartz veins are called lodes. A recent uplift of the Sierra happened 5 to 10 million years ago. The mountain range rose to its current height, and this rise was caused by normal faults tilting west. Some rocks found here include granite, which is composed of biotite, mica, quartz, and feldspar. And this granite is igneous intrusive and was created by subduction during the Jurassic and Cretaceous age. Granite comes out of Earth's crust when the tectonic plate snaps.
Basins and ranges of northeastern California. This area was formed 14 million years ago and is located in northeast California. Here are the numerous large faults that make multiple elevated blocks or ranges and lower basins. One example that we saw was the escarpment of Sally. The terrain here is caused by tensional stress to create a range and basin. When the plate stretches, it causes multiple faults and eventually snaps. Once it snaps, the area falls and becomes a deep basin. The two upper sides are then referred to as the ranges. The ranges are made of rock that is harder to erode, while the basins below them are made of the sediments from the ranges that are easier to erode.
Volcanoes in the Cascade Range and Modoc Plateau. The volcanoes in the Cascade Range and Modoc Plateau are volcanoes that erupted in the past 3 million years. The Cascade Range includes Mount Shasta at 14,000 feet elevation, Mount Lassen at 10,000, and multiple other prominent mountains. Shasta and Lassen are currently the most famous for being active. Mount Shasta is one of the largest composite volcanoes in the Cascade chain, and it was constructed over the past 100,000 years through hundreds of eruptions. These eruptions produced lava flows, pyroclastic flows, and debris flows around the mountain base. Mount Lassen is not a composite volcano, as most are in this area. Instead, it's a lava dome volcano, so it's very steep-sided. Mount Lassen was formed by magma above a volcanic conduit. Rock in this area is mostly dacite, and which is silica-rich, and it was from around 11,000 years ago. Other popular areas surrounding are hot springs, boiling mud pots, and gas discharging fumaroles. The Modoc Plateau is a high lava plain that is east of the Cascades. It is 4,500 feet in elevation, and many other volcanoes are on this plateau. It's around 26,000 square kilos.
Ice ages. During the Pleistocene epoch, California was affected by climatic oscillations. These are cool intervals due to glaciers growing in the high elevations of areas such as the Sierra Nevada or the Cascade Range. Valley glaciers in the mountains make U-shaped valleys, horns, and cirques in the bedrock exposures. When a glacier moves, it carves out a ridge because of the rock it pushed forward. This creates the lateral and terminal moraines. Then, the area where the glacier was eventually turns into a lake. These glacial erratics are commonly found in mountains that are above 2,000 meters in elevation. In the lower elevations, there are lakes that expanded and decline along with the Pleistocene climatic cycles. The sea level constantly shifted and changed. During glacial advances, it fell as much as 120 meters. And the San Francisco Bay actually was the river valley, and the location was where rivers flooded out of the Pacific Ocean. When the glaciers melted in warm weather, the sea level rose. The modern formation of the bay formed around 8,000 years ago when glaciers melted due to warm climate.
Earthquakes. Earthquakes occur due to converging plate interactions and are commonly located in areas such as the Cascadia Subduction Zone, San Andreas Fault, or the Owens Valley Extension. They are in relation to the transformation boundary between Pacific and North American plates, to the south and along the normal fault zone at the base of the eastern escarpment of the Sierra Nevadas. The San Andreas Fault was a part of the transformation plate boundary, and this area historically has the largest earthquakes. Earthquakes, as shown through intense ground shaking, lead to the following: collapse of structures, liquefaction, landslides, and fires. They are also very expensive in reconstruction, and the 1906 SF earthquake was one of the most destructive and well-heard-of ones. Geologists can look ahead and predict earthquake forecasts. These are based along active faults on the basis of ground motion and strain measurement. Seismic gaps are dangerous, so when something hasn't moved in a long time, tension builds up and then releases to cause an earthquake. The longer the wait, the larger and more destructive earthquakes can typically be.
That concludes the simplified history of California's geology. Thank you for watching.